All right, good afternoon, good morning, or good evening, depending upon where you are in the world, and welcome to today's Security Boulevard webinar broadcast. I'm Charlene O'Hanlon, moderator for today's event, and I welcome you. As always, we have a great event on tap, but before we get started, we do have a few housekeeping items we need to go over. First of all, today's event is being recorded, so if you miss any or all of the presentation, you will have the opportunity to access it later on. Following today's webinar, we will be sending out an email that contains a link to access the webinar on demand. And we are taking questions from the audience. So if at any time during the presentation you have a question for our speaker, please don't wait, don't hesitate. Just use your question and answer tab on your interface and submit your questions, and we will try to get to as many as we can near the end of today's webinar. We also have a very public chat feature, so we encourage you to use it. Go ahead and chat us up with your questions, comments, etc. Anything you want to share with us, we'll be more than happy to chat you back. All right, and at the end of today's webinar, we are doing a drawing for 4 $25 Amazon gift cards. So please stick around. Hopefully you will be one of our 4 lucky winners. Okay, with that, let's go ahead and kick off today's webinar, which is Managing Open Policy Agent at Scale, or Authorization for the Cloud Native Ecosystem. Our speaker today is Tim Hinrichs, who is the CTO and co-founder of Styra, and also the co-creator of OPA. Tim, thanks so much for joining me today. It's great to see you, and I know it's going to be a great presentation.
Thanks so much for having me, Charlene.
No problem. Well, I'm going to take myself off camera, put myself on mute, and let you get right to your presentation.
Great, thanks. All right, so as Charlene mentioned, today we're going to be talking about authorization for the cloud native ecosystem. And so I wanted to start out with just a few words about authorization. It's a word that, especially in the security community, we hear quite a bit, but it's worth talking about for a minute or two. So authorization really is the problem of controlling what actions people and machines take on software. So we've got a couple of very simple examples there. Can Alice, if she's trying to withdraw some money from some account, is she allowed to do that? If Bob's trying to query some production database, is he allowed to do that? If some service is trying to run an API call to extract a bunch of invoices from some other service, is that authorized or not? So that's the authorization problem. It's a problem of can people or machines, are they allowed to perform the actions that they're trying to perform or not? And authorization is really a problem that is often or can be confused with another problem in the security space called authentication, right? So authentication is the problem of identity. It's proving to a machine that you are who you say you are, and it's usually solved with usernames, passwords, multi-factor authentication. So that's the authentication problem. Who are you? Are you Bob? Are you Alice? Or are you Service 456? We're not going to be talking too much about authentication today. It is important to solve authentication if you really want to think about security in software. But what we're going to be focused on is authorization. So once we know who you are, what actions are you allowed to perform, that's the authorization problem. And that's the problem that we're going to be talking about today. Now, one of the observations that we make about authorization is that authorization is a problem that is inherent in really all software on the planet, right? Every piece of software that's really ever been built has to decide when a user is trying to perform an action, is it authorized or not? Is that action allowed or not? Today, we're going to focus on the cloud native ecosystem of software. And so that's what this picture is designed to show. It's designed to show all those different pieces of software and therefore all the authorization problems that you'll encounter if you're an organization, maybe an enterprise, that's trying to embrace this new movement around building and running custom software applications. So that is cloud native in this picture. The idea here is that I'll call out those sort of 3 main pillars of the cloud native ecosystem. You've got CI/CD pipelines. That's where you've got developers pushing all their code, and you're using those pipelines to deploy that code to build applications, to actually deploy and run applications. In addition to those applications are running on a platform. And so those are the 3: the CI/CD pipeline, the application, and the platform. You see all 3 of those here. But what I'll also call out there, sort of in those blue boxes around those 3 pillars, are a slightly more fine-grained view into those 3 pillars of cloud native software.
Hey, Tim, sorry to interrupt you, but we just got a message in, a question from somebody that I thought you might be able to address right now. Michael is asking if you would give an example of an Auth-Z use case where OPA is not appropriate.
Oh, that's great. Well, yeah, so great question. I was about to articulate where OPA is appropriate, which is shown in this slide. And so let me do that, and then I'll go ahead and answer the question of where maybe is it less appropriate. So I think it was Michael. As Michael pointed out, there are all kinds of places where authorization shows up in this cloud native ecosystem. In CI/CD pipelines, anytime somebody's trying to commit new code or deploy an application, there's an authorization problem that needs to be solved. At the microservice or at the application level, we've already seen a couple of these on the last slide. Every time an API gets called, there's an authorization problem. Is it safe to run this API or not? At the database level, anytime somebody's trying to query a database, there's an authorization problem. At the Kubernetes level, every time somebody's trying to spin up a new resource on Kubernetes, there's an authorization problem. At the public cloud level, same idea. At the server level, every time somebody's trying to SSH into a Linux box, is that authorized or is it not? So authorization is everywhere. That was one of the founding principles around Styra and Opa. And so one of the ideas here is that because authorization is everywhere, the challenge is that each and every one of the products and projects that you kind of see illustrated here have their own solution to authorization. And so if I'm an operator, if I'm someone who's responsible for the safety, security, the compliance of a stack of software like you see here, if I want to know who has access to what, I've got to go and talk to 57 different APIs, GUIs, even models for authorization. I have to figure out how to extract that information from each and every one of these products, and it's all different. And similarly, if I'm trying to write or put authorization policies in place, then again, what you'll see here is that there are 57 different things that I have to know and understand in order to make that happen. So at the end of the day, you've got a bunch of you've got a common problem that's shared across all these different pieces of software, but there are different solutions for all of those. And so at Styra, this was the problem that we saw when we started the company, and there were really two pieces of software that we built to address it. The first of which is called the Open Policy Agent Project. This is, for those of you who haven't seen it, this is a totally open source project. We started at Styra, but then we donated it to the Cloud Native Computing Foundation. I'll talk a little bit more about some of those details a little bit later. But the goal for Opa is to provide a unified solution for policy and authorization across this cloud native ecosystem. And so I think it was Michael pointed out a little bit earlier that Opa can be used for all of the use cases you see here. Not only can it be used for these use cases, but each of these categories of use cases are one that Opa has been used in production at scale by somebody in the world today. So this is not an aspirational slide. This is really a slide that shows where Opa has been deployed in production. So, a couple of the more popular ones would be using Opa for Kubernetes. That's really popular. That would be, you can go and listen to good talks by Intuit and Capital One to hear how they as end users embraced Opa and why they did. Pinterest talked about using Opa for Kafka authorization. Netflix, Atlassian, and others have talked about using Opa for microservice level authorization, and so on and so forth. So this is a good picture that shows where Opa can be used to solve the authorization problem. And importantly, what Opa does, what it aims to do is provide one language for expressing all these authorization policies. It provides one framework for enforcing these policies, one tool set as well. So once you learn and understand Opa and how it's used, you can very easily then take that knowledge and apply it to all kinds of different domains and use cases. Now, the question that came up was where maybe are good examples of where Opa might not be the right solution. The one that jumps to mind here is when you're starting to talk about like packet level authorization, like at the router level of a network, right? If you're thinking about putting Opa in place, rolling it out into routers, that's probably not the right place, right? The performance requirements are just too high for Opa, at least today. We have seen mechanisms where people will take Opa policies and compile them down into something like IP tables. And if you really wanted to embrace this this vision of unified authorization, like completely universally, that's the kind of approach that I would probably recommend, is expressing those policies in Opa's policy language, but then compiling them down into lower level enforcement mechanisms. So one of the goals here for Opa is obviously to provide that unified solution to policy and authorization across this cloud native ecosystem. But at the same time, Opa was designed to embrace this sort of cloud native approach to software development. And by that, what I mean is that what we see in cloud native is many different components, many different pieces of software that are rolled out in a fairly replicated and distributed manner. And so, like, let's take microservices, for example. In a microservice application, you don't have 5 or 10 instances of your service. Instead, you have hundreds or thousands of instances of your service. And what you want from an authorization solution is not just a single language for expressing those policies, but you want an enforcement mechanism that meets the availability and performance requirements of that microservice application. And so one of the things that Netflix articulated well when they talked about why they chose Opa was that in a microservice world, what you really want to do is have those authorization decisions running and evaluating on the same server as each and every one of your microservices. And the reason for that is because what you don't want to be doing is paying for a network hop in order to get that authorization decision, because there's so many network hops in a microservice architecture. And so that's why one of the reasons they picked Opa was because Opa was designed to be able to run at the edge of your architecture, whatever that edge means to you. But in the microservice case, what it allows you to do is run one Opa on every server that's running a microservice. So if you have 500 instances of your microservices, then you'll have 500 instances of Opa. Opa allows you to go ahead and make a copy of all of the policies that it needs to actually make decisions. And in so doing, it gives you those availability and performance requirements that you need in order to successfully solve authorization in this cloud native ecosystem. All right, now that is Opa. It has been used in production by hundreds of companies at this point. But what this picture is great because it shows where Opa can be used, but it also kind of shows architecturally what I was trying to talk through a moment ago, which is that you don't have 1 or 5 or 10 instances of Opa. You end up with maybe hundreds or thousands of instances of Opa. And what that does is it begs the question, well, how do you manage all of those Opas? And that's where the second piece of software that Styra has built comes into the picture. So Styra has a commercial product called the Declarative Authorization Service. It was designed to be a management plane, a control plane, a single pane of glass for Opas across all the different use cases that you can deploy Opa for. So any sort of use case that you connect Opa to that you want to manage policies with, you can go ahead and use the DAS to manage those policies. It provides a number of tools around helping you author policies, around testing those policies, distributing the policies to all the Opas, gives you interesting information around telemetry and logging. So anyway, that's really the two pieces of software that at Styra we have developed that help that together really deliver this vision of unified authorization for the cloud native ecosystem. Now, what I wanted to do for the rest of the slides before we get to a demo of how this all works is talk a little bit about each of Opa and the DAS, just to see if, to give you maybe one more level of detail about each. So the first question that we often get asked is, well, how does Opa integrate with all of those wildly different projects and services? And so here's the way that almost all of these integrations work. We have a service. That service could be really any of those icons that you saw in the last slides, whether it's Kubernetes or a microservice or a service mesh or Kafka or Linux. That service decides that it needs an authorization decision. And so it cobbles together whatever information is pertinent to that decision as a policy query. It hands that policy query over to Opa. Opa goes ahead and makes a decision and it returns that decision to the service. It's the service's responsibility to enforce that decision. It is Opa's responsibility to make the decision. So that's how we look at the separation of responsibility there. Now, there are a couple of other things to call out here. I'll focus on one of them, which answers sort of this broad question. Well, how can Opa possibly work with all of these seemingly quite different use cases? And the answer is that that policy query that gets sent to Opa is just arbitrary JSON, in the sense that Opa does not know the real world meaning, the real world semantics of what that JSON represents. Opa just sees it as JSON. So for example, if that service were the Kubernetes API server, the API server would hand to Opa a policy query that represents the 200 lines of, let's say, JSON or YAML that codifies whatever the Kubernetes pod or the ingress or whatever other resource that end user is trying to spin up on the cluster. Opa doesn't know what the pod or ingress is. It just knows that it's handed some JSON. Likewise, if that service is a service mesh like Envoy, Envoy will just hand over, maybe it's a triple, which represents the user, the method, and the path that is trying to be executed. Again, Opa sees that as a JSON object. It doesn't know or understand exactly what the real world semantics of that JSON object is. So the way this works is, of course, is if Opa doesn't know, I as a policy author, I'm the person who knows what the real world meaning of a Kubernetes pod or an ingress or a HTTP method, path, and user represent. And so then therefore I can write the appropriate policy to make the right decision and hand that decision back to the service. So that's the short version of this slide. Certainly I can talk more about it if folks have questions. But I think that hopefully illuminates how you can apply Opa to so many different use cases across the cloud native ecosystem. As I mentioned earlier, Opa is a completely open source project. We started it back at Styra in 2016. We donated it to the Cloud Native Computing Foundation in 2018. And then if you haven't seen the CNCF before, there's this ladder of maturity. You start at sandbox, you move ahead to incubating, and then finally you end up at graduated. So we graduated in 2021, or Opa did. And that graduated level is the same level that Kubernetes, Prometheus, Envoy, and some of the most popular cloud native software exists today. Plenty of good contributors and users. Go ahead, and I would recommend checking out the CNCF dev stats if you want more information there. The other thing I like to do, I mentioned some of this earlier. Whenever I'm looking at a new open source project, I always like to sort of understand that project through the eyes of users who have gone ahead and deployed it. So if that's what you're looking for, I wanted to point out a good collection of end user talks, a good dense collection of end user talks. Go check out the KubeCon US 2019. There are really two kinds of talks that you'll find there, one of which is sort of the main tracks where you can hear those folks at the top, Yelp and Goldman and Snyk and Reddit, talk about how they're using Opa. And you get a sort of a mix of different use cases. Some are microservices, some are Kubernetes. But then also check out the Opa Summit. We held one of these, again, at this KubeCon US 2019, where we just had a bunch of end users come and talk about how they're deploying Opa. And again, you get a nice collection of different use cases there to listen to. So Cap 1 was talking about Kube, and Chef was talking about using Opa as to solve the application authorization problem. Pinterest had a couple of different use cases, Kafka and microservices. TripAdvisor was looking at testing around Kubernetes. And Atlassian was looking at microservice authorization. So definitely check out those talks if you want to hear from the end users about how they're using Opa. Okay, so that was all I really wanted to go through with Opa, at least the next level of detail. Hopefully that sheds some light on how Opa integrates with all these different kinds of projects that you see on the slide. And also gives you a sense of who else is using it, and hopefully you've got pointers to understand the project through their eyes. Here, really, I want to transition and say a few words about the second piece of software that we built, Styra's Declarative Authorization Service. Remember, this is the management console that allows you to control, allows you to author policies, test them, distribute them to all those Opas. It gives you that single pane of glass to help you understand what's going on and to manage all of the policies throughout an organization. The key thing that I want to call out here is that, and I'll go back a slide, the key thing I want to call out here is that this picture sort of illustrates to me sort of the goal of unified authorization, having that single pane of glass wherein you can both read and write the policies that show up throughout all the different software in your environment. And all those different pieces of software are sort of illustrated here by these logos. So I sort of think about this as, think of these as the real world software systems that you're managing the policies for. And so that's why I love this slide, because it shows not only the use cases, but also it gives you a sense as to how I like to think about what unified authorization means. And so if I transition over to the screenshot here of DAS product, what you'll see is basically that same slide. So here under the systems heading on the left-hand side, you'll see a number of different icons, and each of these different these entries, each of these different systems represents one of those real-world software systems that you're managing policy for. And so I always like to think of the product as basically a real-world instantiation of that slide that you've now seen a couple of times. So in this particular example, we have three Kubernetes systems. Kubernetes is that icon with a blue and white wheel. We've got two different Envoy use case, or two different Envoy fleets of microservices there. That's that purple icon. And then what you also see is a number, 3, 4 of these different Opa icons. That's what that little gray icon is. And that's the icon that, at least today in the DAS, indicates that this is some use case that's not one of the pre-built ones, but rather is one of the custom use cases that customers can go ahead and roll out however they like. So that's sort of the DAS and what it aims to do. It aims to provide that unified control over all of these different real-world systems, the policies specifically that are enforced and monitored across all those systems. Now, one thing that I like to think about is the kinds of features that exist within the DAS, in my opinion, fall into these two categories. They fall into either policy lifecycle management. So imagine you're a single developer and you're embracing Opa, and then as soon as you do that, one of the benefits is that Opa embodies this notion of policy as code. So policies exist in once you're using Opa, policies exist in file formats that you can then think and you can treat as if it's real code, as if it's Java code or Go code. And because of that, now you can take those files and put them through a whole life cycle, right? You think about authoring policies, you think about testing them, you think about deploying those policies to all the Opas, you think about monitoring the health of both the Opas as well as the decisions that are being made. And so that whole life cycle is something that the DAS has a whole bunch of features to help make especially smooth. And so this is one of those scenarios where I think the whole is better than the sum of the parts, in the sense that by integrating all of this life cycle into a single product, what you end up with is the ability to create features that you wouldn't be able to if you treated all of these elements of the life cycle separately. So for example, there's a nice feature that we like to call impact analysis, where because we're able to store all of the decisions, the log of all the decisions that Opa is making in the DAS, we can then, at the time at which you're authoring policy, do testing that allows you to go ahead and replay all those past decisions on a new policy that you're thinking about deploying to production, and assess what impact that new policy would have before you even deploy it. And so maybe you find out that this policy change that I'm about to make ends up with a 10% change in historical decisions. 10% of the old decisions used to be allowed, but now they're denied, or vice versa. That seems like maybe that's a safe change to go ahead and push out to all the Opas. But maybe you find out that after you do this impact analysis that 90% of your past decisions have changed from allowed to denied. Well, that seems like a pretty scary change. And so that's certainly something that using the DAS allows you to have that insight that you just wouldn't have before. All right, so that's one class of features that we have within the DAS. And the way I like to think of that is, even if you're a single developer, you need to think about that entire policy management lifecycle, and so you need all of those features in one place. On the other hand, the other category of features that I like to think about are what I'm calling here enterprise-grade governance. So the nature of policy is that it's one of these things that you need an entire team to help define and understand, right? You think about not just the teams that are responsible for the Kubernetes cluster, or that are responsible for the service mesh, or they're responsible for the cloud or the CI/CD pipeline, but you're also thinking about how all of those teams interact. You think about how the security and compliance teams are responsible in some way, shape, or form for a lot of those policies as well. So policies itself, one of these is really a team sport. And so having the other class of features that we have in the declarative authorization service are features that are designed to make policy management in a team setting especially smooth. So I won't go through the details there, but I wanted to put those two categories of features into your head. All right, and so now we'll go ahead and switch over to do a demo. Yeah, I was just checking to see if we had any other questions? No. All right. So we're going to do a demo, and what you're going to see is mainly the declarative authorization service. But what's happening under the hood is Opa, right? Opa is running. I won't go and show you actually Opa running, but nevertheless, that's happening under the hood. So what you're seeing is both of these different pieces of software working together to provide that solution to unified authorization across the cloud native ecosystem. So hopefully this sort of looks familiar because we've already gone through. I've already talked a bit about this screen on the screenshot a little bit ago. Remember, here on the left-hand side, what we see is a list of all the real-world systems that we are actually managing policy for. So 3 Kubernetes systems in this case, 2 Envoy systems, and it looks like 4 of these Opa, what we like to call the custom use case. And so the idea here is that if you're an operator and you're trying to manage Opa for a new system, maybe it's a new Kubernetes cluster, a new microservice fleet, you would go ahead and just create a new system here. You would pick which type you're trying to use. You give it a name and so on and so forth. And then immediately what would happen is we would go ahead and show you, here are some install instructions that you can use to go ahead and actually deploy Opa and get it configured to correctly talk to the DAS. And so we try to make that install process as simple as we can. And then once you go ahead and get Opa installed and running in your real world system, then immediately Opa is going to start making decisions, right? At least once you load it with policy. So I'll show you how you load it with policy in a little bit. But once you get Opa out there with a policy making decisions, what you'll see is a dashboard like this one. So this dashboard is showing you all the decisions over time that Opa is making on this particular Kubernetes cluster. And so what you see here is that greens are allows and blues are denies. And then it turns out with Opa, if you haven't seen this before, with Opa, you can make decisions that are not simply allow or deny. You can make certainly more complex decisions. And here we see that purple color is representing decisions in this case that are telling the Kubernetes API server to go ahead and mutate certain resources before they get deployed onto the cluster. So that's why you see 2 different graphs there. But at the end of the day, you've got time series graphs. These are all the decisions that are being made. And then you also see latency here down below. So that's a good thing to keep track of over time. As you deploy new policies, how does the latency respond? If there's more activity on the underlying system, how does the latency respond, and so on and so forth. Now, this is a sort of aggregated view of the decisions that Opa is making over time. And so what sometimes people really want to do is go ahead and look at the individual decisions that make up that graph. And so that's what I did there. I clicked over to that decisions panel. And what you see here is something that looks kind of like an Apache-style graph. Sorry, an Apache-style log. It kind of just looks like the standard kind of logs that we see. But in this cloud-native world, one of the things that we see over and over is more and more attention is paid to being able to have sort of like JSON or rich data representations of the information that we're storing. And this is a good example of that, which is that here, if we open up any one of these log entries, really these log entries are JSON objects that represent exactly the inputs that were handed to Opa, the decision that Opa made, and it even includes a pointer to the policy that was used to make that decision. So there's enough information stored in each of these Opa decision log entries to let you replay these decisions at a later point in time. And then what we do, just for the sake of human beings trying to consume these things, is we render each of those JSON objects in a more human-friendly, human-readable way. So that's the decision log. That's kind of some of the monitoring, some of the telemetry that you get using the DAS. But to really understand why these decisions are made the way they were, we should take a look at the policies and how you put those in place. And so here what we have is a view of the policy editor for this Kubernetes system type. And so what you see here is that there's a sort of card view where you've got sort of like 3 swim lanes where on the left-hand side, you've got some rules that you kind of have in there, but they're not really being used at all. The middle lane here is really for rules that you're putting into monitoring mode. So don't put these rules in there. Don't enforce them, but tell me when there are violations. And then the right-hand side here, the right-hand swim lane is for enforced rules. These are rules that once they're in place, that Opa will take them, and if a new resource that somebody's trying to create on the Kubernetes cluster violates one of these rules, then Opa will go ahead and reject that new resource. And so these will actually be enforced on the cluster. And so these are shown here as cards, which is a nice way of sort of understanding what the policies are that are in place, especially for someone who need sort of a higher level view of the policies that are in place. One of the nice things about the Kubernetes use case is that we can provide a bunch of these rules pre-built out of the box so that you don't have to write them yourself. You do have the option of writing custom rules. That's part of what Opa provides, part of the core value that Opa provides. But in the DAS, what you see here is that we've got a bunch of pre-built rules so that you don't have to worry about it. Now, these rules come out of a number of different places. We've mapped different compliance packages down into Kubernetes admission control rules and then codified those here. So there's PCI, there's a best practices list, there's a pod security policies, there's CIS benchmarks as well. So what I did there was I added a new rule. I happened to just pick one out of the list. Here I added a rule that says I want to enforce some labels. And so let's go ahead and do that. Let's say I've got a crazy label that I want to enforce. I'm going to say all resources need to require this long foo kind of resource, this long foo label. And now, I've got this new policy ready to go. Now, nothing's happened yet. This is all sort of a draft, as you can see over here. But as soon as you're ready to go ahead and, actually enforce this down and distribute this policy down to Opa, you could go ahead and hit that publish button, and the policy would be soon downloaded to Opa, and Opa would start enforcing it. But what I would want to do, I would be very nervous as a policy author about what the impact of this policy will be. And so what I want to do is hit that validate button. That validate button does that kind of impact analysis that I talked about a little bit earlier. So here the idea is I want to know what impact that new policy will have on my real world cluster. And so what you see show up here are really three different categories of ways to get insight into that impact. The first of which is unit tests. So if you're writing custom rules, then we do recommend you writing unit tests. You don't have to write the unit test for the rules that are pre-built. But so we'll go ahead and run those unit tests for you here. More interestingly, though, is this middle pane. So this middle pane, what's happening is that we're going out onto the live cluster and we're grabbing whatever resources currently exist, and we're running them against this new policy, and we're flagging the resources that violate the new policy and that would cause problems. And so what you see here is that there are 273 new violations on the cluster. And so then you also see that labeled up here. The right-hand pane is doing that sort of impact analysis that I talked to a little bit ago, which is saying, hey, go ahead and take that previous history of decisions that we saw just a moment ago in that different tab and rerun them using my new policy and count how many of those old decisions are made differently with our new policy. And so in this case, we've got roughly 100 changed out of 255. So what is that, 40% or so? So 40% change is pretty substantial. I'd be pretty nervous about trying to put this rule into place. One other thing that I mentioned here is that you can go ahead and write your custom rules. So in this view, it's not really clear how to do that. But if we go ahead and click over here to the code view, what you see is that each and every one of those cards is underneath it. Really just a representation of the policy as code that is defined by Opa. So this code over here represents and implements the rule that you see in the card on the left. So you're free to go ahead and write whatever rules you want. Obviously, if it were me, I would go ahead and check if the rule already exists before I go ahead and write my own. A couple other things that I'll mention here. One of which is that, here I've sort of just shown you that, yes, we are storing these policies in the back end of the DAS. But what a lot of people like to do is go ahead and store their policy as code in a Git repository. And so you can go ahead and do that. You just simply configure the system to store all the policies in your Git repo of choice. And then instead of having a publish that goes directly to the Opas, the publish button will go ahead and send that policy to a private branch in your Git repo. And then you'll be able to go through the standard peer review process before you merge that policies code into your main or your master branch.
Hey, Tim, we've gotten a couple questions in. I thought now might be a good time to ask them to you, if you are down for that.
Perfect.
Okay, great. So Daniel sent in two questions. First one is, how is self-consistency of the policies checked? What happens if there are conflicting or contradictory policies?
Yep, that's a good question. So typically the way, so this is really an Opa question. So with Opa, the way this usually works is that allow and deny are different statements. So you can, in fact, there are good reasons to go ahead and simultaneously allow and deny resources. What you need then is a way of resolving those conflicts. That's how we like to talk about it. So if a resource is both allowed and denied, or a request is both allowed and denied, then what is the eventual answer? And with a lot of prior work in this space, they would have a handful of built-in resolution algorithms. But with Opa, the language is sufficiently expressive that you define your own conflict resolution mechanism. And so, with AWS, for example, deny overrides allow. It's a very sensible kind of conflict resolution mechanism. With Opa, you can certainly define it that way. You could define it so that allow overrides deny. And then you can set defaults as well. So you have quite a bit of power and flexibility to customize that conflict resolution however you like. One of the benefits of this approach is that conflict resolution is one of the benefits of this approach is not just that you can handle this very simple allow deny which one takes precedence, but you can even think about conflict resolution at the team level. So imagine you had one team that's responsible for compute resources, one that's responsible for networking resources. They each write their own policies independently. And now the question that comes in is like, here's some new resource, let's say in Kubernetes. Maybe it's got a bit of compute and a bit of networking. So how do you resolve a conflict if the compute team allows it and the networking team denies it, or vice versa? Maybe it's a team-based kind of conflict resolution. And that kind of team-based conflict resolution is something that you can express in Opa as well.
All right. Question. Yeah, it is a great question. And he has another question for you. Is there a way to list allowed actions? For example, if I want to list them in some UI?
Yep. So asking for all the actions that are allowed. Yeah. So one of the interesting things that you can do with Opa is like iteration is a built-in concept. And again, it's very different from a lot of prior work in this space. So with iteration, one of the things you can do is you can actually say, just, go ahead and iterate through and give me the list of all of the actions that this user is allowed to perform. So one of the things I didn't go into too much detail on there was Opa's ability to return decisions that are not simply true or false. Opa can return really any JSON object. So in this case, the way I would imagine it is that you would write a policy that returns the list of actions, let's say, that this end user can perform. It's another great question.
All right, I'll let you carry on.
All right, so we've covered some of this policy authoring. And then we've sort of talked about, we've also seen how the decisions that Opa is making down on the real cluster are available to you, both to browse, but also to analyze. And then we talked about how impact analysis sort of ties all this together. So you can write policy, you can analyze it against that previous list of decisions. The other thing that I'll call out when it comes to policy authoring here is that up here, what we've really talked about are these individual systems. So each system in the real world that has some policy that we need to manage for. But sometimes what you end up with is, in this case, maybe 3 Kubernetes systems. That's fairly easy. But in some cases, maybe you have 50 or 100 of these systems. And so then you start thinking about, well, how do I manage the policies across all these 100 systems? Do I have to copy paste all my policies from one system to another? And the answer is no. That's what the stacks feature is designed to do. The idea here is that you can write whatever policies you like in what we call stacks, and you use the same kind of policy editing experience. But then what you do is you dictate for each one of these stacks which of the individual systems the policies in the stack should be applied to. And so you get this notion of global policies, but then you get the ability to choose which systems those stacks apply to, and you choose that through just a basic label selector, like so many of us know. So that's one of the other key features that you start thinking about when you start thinking about sort of enterprise-grade governance, is how do you work with teams across when you have many, many different software systems that you're trying to manage the policy for.
I got another question in. Do you want to take it? All right. Yeah. Michael asks, what capability does DAS have for promoting policies across environments?
Yeah, so typically what we see people do is treat, typically what we see people do is, if you think about like, I don't have any examples here, like if one of these were, dev and one were staging, one were prod, typically what we see is that people have different policies in each of those different systems. And so we don't today, and so they'll just like move policies from one to the other because they have to at the end of the day. What we see more often when I'm thinking about promotion is more this use of stacks, where what they want to say is all of my production Kubernetes clusters need to have these common policies in place. And so that's really what we see. And so what we'll see more often is that there's a production stack, and there's a dev stack, and there's a a staging stack.
All right, that's all the questions that I have here for you now. So you can go ahead and continue on, and I'll interrupt again as necessary.
Perfect. Thank you, Charlene. Okay, so the only other thing that I wanted to show here in the demo was that we've talked for the most part about Kubernetes, this Kubernetes system type, as we like to call it. But there are other system types as well here. That Envoy has a system type it's a bit different in the sense that in this one, what we do is we help you write policies for ingress traffic to control the APIs that are coming into a microservice. You can also write policies that control the egress traffic, the traffic that the microservice is sending out. And then you can even write policies that are more at the application level. So maybe here, this isn't just an HTTP level kind of policy, but rather it's a policy about, can Tim withdraw money from this account, right? Well, Envoy in that case is not going to have enough information to actually make a decision on the ingress or egress, but rather it's the application that needs to talk to Opa in order to get that decision. And so you can write those policies here as well. The other one here, the other system type that we have is this Opa, this sort of custom system type, and that just has sort of that gives you a very simple interface to writing really any kind of Opa policies that you like. All right, so I think that pretty much does it for me. I just want to make sure that y'all can get a hold of me and look into get some more information. So if you want to check out Styra, that's styra.com, Open Policy Agent. Check that out at openpolicyagent.org. And then you've got my contact information there as well, TL Hinrichs on Twitter. So thank you all for giving me your time. And I'm happy to take questions if there are any more.
Yeah, so we do have a couple here, and Daniel just sent us another one. Thank you, Daniel. There plenty of time for questions, guys. If you do have one, please go ahead and send it on in. Let's look at Daniel's. Is the language the policies are written in Turing complete? And can running it result in the halting problem, or is it a restricted language to make it easier to audit?
Yeah, great question, Daniel. So it is not Turing complete. The policy language is called Rego. It was designed, if I think of one-dimensionalizing the expressiveness of really all these languages, at the least expressive end of the spectrum, you've got things like role-based access control, attribute-based access control, IAM, ACLs. At the high end of the expressiveness spectrum would be all the programming languages like Go and Java and Python and so on. So Rego sits in between. It is far more expressive than the low end, the R box and the A box. You can encode all of those in Rego, but it's certainly less expressive than programming languages. So it is not Turing complete. And that balance is really important for these policy systems, for the simple reason that you want something that's expressive enough to be able to do things like if you're trying to write a policy over, let's say, a Kubernetes pod, you need to be able to dig down through that JSON object that represents the pod. You need to be able to find the list of all the containers. You need to be able to iterate over all those containers, and you need to be able to do some string manipulation to figure out whether let's say, the images are all coming from a trusted registry or not. So you need enough expressiveness to be able to write down the policies that you actually care about at the end of the day. But at the same time, what you want from a design point of view is for Opa to be to shoulder as much of the burden for performance as you possibly can. And so in order to do that, what you want to do is guarantee that that it's not a programming language. It's not as expressive as any programming language, because you need to do a whole bunch of automated optimizations to handle the performance and try to alleviate as much of the performance concerns from the end users as you possibly can. And so that's why Rego sits where it does. It's got to be expressive enough to handle all the policy requirements that we see in this cloud native space in terms of being able to write the policies you want. But at the same time, it needs to be its performance needs to be auto optimizable. And so that's why it sits sort of in between, and it's closer to like a query language like SQL than any of the others.
All right. Let's see if we have any other. Yep. Okay. Oh, interesting one from Rakib. Can you implement OPA in a serverless environment?
Ooh, that's a good one. Yeah. So one of the new things that we've been working with in the Opa space is adding support for Wasm. The idea here being that you write your policies in Rego, and then what we'll end up doing is compiling those policies down into Wasm, so Webassembly. If you haven't seen this, First time I heard about it, I thought it was only useful for browsers, but really it's just a binary instruction format that's being implemented in a bunch of different programming languages. And so the idea here is that you can use Wasm with Lambda. And so as long as your Lambdas support as long as your Lambdas are written in a language that has that Wasm library, you can go ahead and take those Rego policies, compile them down into Wasm, and have them executed inside the Lambda as part of that Wasm library. So that's certainly one of the reasons that we started looking into Wasm in the very early days was being able to extend its reach to things like Lambdas.
All right, great. Okay, next question here. Here's an interesting one. How much overhead does Styra DAS add to Opa decisions?
Yeah, that's a good one. Yeah, so let me pull up the picture here. So here's the picture of how Opa and DAS relate to each other. So the thing to keep in mind here is that Opa, the short answer to the question is there's no overhead added to Opa decisions because of the DAS. The reason this works is because Opa is going to have a host local cache of the policies it needs in order to make decisions. So and because of that, whenever that's in service goes ahead and asks Opa for a decision, Opa makes that decision entirely without talking to the DAS at all. Opa only talks to DAS in order to download new policies and then upload decisions. But the actual latency for making decisions is completely contained within Opa itself.
All right, let's see. That looks to be all the questions that have come in so far. I'll leave the question and answer open for a minute or two to see if we get any more in. While we're waiting, just a quick reminder to the audience that today's event has been recorded. So if you missed any or all of it, or if you just want to watch it again, you'll have the opportunity to do so. We will be sending out an email that contains a link to access the webinar on demand, and the webinar is also going to be living on the Security Boulevard website, so you can always go look for it there. Just go to securityboulevard.com/webinar and look webinars and look in the on-demand section, and it should be right there waiting for you. Okay, doesn't look like we're getting any more questions in, so real quick, let's go ahead and do the drawing for the 4 $25 Amazon gift cards, and then we'll give everybody a few minutes back in their day. Our first winner today is Jonathan S. Congratulations, Jonathan. Our second winner today is Ricardo G. Congratulations, Ricardo. Third winner today is Joel J. Congratulations, Joel. And our final winner today is Derek W. Congratulations, Derek. Congratulations to all 4 of you. We'll be checking in with you via your email to get your Amazon gift card over to you. So please check your inbox. And if you don't see it there, please check your spam folder. Tim, great presentation. I'm a big fan of demos, and so I just really enjoy watching what's going on behind the scenes. So thank you very much for sharing Styra DAS and OPA and all that good stuff. So thanks again. Really do appreciate your time and your expertise.
Thanks so much, Charlene. This was a lot of fun.
Excellent, excellent. Well, I also want to thank the audience for joining me today. This is Charlene O'Hanlon, and I am signing off. Have a great day, everybody, and please stay safe.